All right. Our statement here reads, a point charge Q is situated at a large distance r from a neutral atom of polarizability alpha. Find the force of attraction between them. Things to know for this problem. The electric field of a dipole, which we found in Chapter 3, and the induced dipole moment. Let's first consider the field of a point charge Q. We know that from Chapter 2, the electric field is equal to 1 over 4 pi epsilon naught times Q over r squared in the radial direction. And thus, the induced dipole moment of this atom is P equal alpha Q over 4 pi epsilon naught r squared in the radial direction. Now, the field of this dipole at location of Q, where theta equal pi, can be found from the given notes, where E dipole is P over 4 pi epsilon naught r cubed times 2 cosine pi r hat plus sine pi theta hat. Note that sine cancels to 0 and cosine cancels to -1. We can simplify this down to negative 2p over 4 pi epsilon naught r cubed, or simply write 2p over 4 pi epsilon naught r cubed to the right. Now, the force on Q due to this field is F equal QE. Note that the E dipole has a dipole moment in it, which is highlighted in blue. We found that previously. Now we need to substitute that into the force equation in order to simplify. This will allow us to write the force in terms of the atomic polarizability. So we note that when we substitute in, we have a common factor of Q over 4 pi epsilon naught, that's the squared, and we note that the r's combine to r over 5, and thus we have the force here, which is an attractive force.